Hey everyone, I'm going to do a short series of videos demonstrating how to draw Lewis structures and all the little details that you'll see along the way. These will be following the steps on the Drawing Lewis Structures document. There are 5 steps. We may not use them all on a particular Lewis structure, but the 5 steps are there, and if you learn the steps and practice the steps, you should be able to draw a reasonable Lewis structure for pretty much any molecule. Now, the first step in the steps for drawing Lewis structures is to determine the total number of valence electrons in your molecule, which involves adding up the total for all the elements that are there. Now, you're looking at a copy of the periodic table, and counting the number of valence electrons is as easy as looking at which column the element is in. Now, I've only used, or labeled, the first 2 columns over here and the other columns over here because those typically include the nonmetals and hydrogen and a couple other elements that actually make covalent molecules. These here in the middle tend to make ionic molecules or ionic crystals, which don't do the Lewis structure steps. So, for example, hydrogen would have only 1 valence electron because it's in column 1, beryllium would have 2, boron would have 3, carbon 4, and so on and so on. So all you have to do is find your element, for example chlorine, look at what column it's in, and that would be the number of valence electron that it has. So let's start with the molecule. This molecule is NI3, which has the name nitrogen triiodide. Remember that covalent molecules are named with an IDE ending and prefixes to tell you how many of each element you have. Note there's no prefix on the nitrogen because there's only 1 of them. Okay, so if I wanted to draw the Lewis structure for this molecule, I would start by adding up the total valence electrons. Nitrogen is in column 5, so it has 5 valence electrons. Iodine is in column 7, and I'm going to multiply that by 3 because there are 3 iodines present. And that gives me a total of 26 electrons. And I like to sort of note that underneath the formula of my molecule. You can do it anywhere you want, but this is just something that works well for me. Alright, so step 2 is to draw the skeleton structure. Now usually the element that is written first goes in the middle, unless it's hydrogen, which doesn't go in the middle. Nitrogen would go in the middle, and I'm going to connect all of the other ones around it with single lines. Now these single lines, right there, represent 2 electrons each. So a covalent bond is a pair of shared electrons. So at this point I've used 2, 4, 6 electrons in my structure. I have to end up representing 26, but right now I have 6. So that's my skeleton structure. It just tells you which elements are bonded to which. The next step, step 3, is to give the outermost atoms an octet of electrons. An octet is a group of 8. Now each of these iodines has 2 associated with it, so they each need 6 more. So we're going to add 3 pairs of electrons to each of the iodines, just to make sure that they follow the octet rule. Okay, so now I count the electrons again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And I've used up 24 electrons. I have 2 more to go. And this is where either step 4 or step 5 come into play. Step 4 says, if you have leftover electrons, which I do here, you put them on the central atom in a pair, even if doing so results in more than an octet. Now this nitrogen has 2, 4, 6, 8, so it has an octet. And so it is, it's achieved its octet. Once in a while you'll get another pair of electrons you have to do something with, and those would go on the central atom as well. But for now, I'm done. All my atoms have 8 valence electrons around them. I've used up my total, and this molecule is finished.